This video is for the direct comparison test. So we're looking at two sequences, A sub n and B sub n. We're going to compare them. Now, they're both greater than or equal to 0, so they're both positive. The direct comparison says that the sum of this sequence, so the series of B sub n from n equals 1 to infinity, converges. If this one converges, and A sub n is more than 0 but less than B sub n, then A sub n also must converge. And the reason for that is that we know if B sub n converges, the series B sub n, then it's headed towards a number when you add all of this up. But A sub n is less than that, so it's more than 0 and less than some number, so there's no way for A sub n, the sum of A sub n, to head towards infinity. So we say the sum is n equals 1 to infinity of A sub n also converges. So what this test says is that less than a series that is less than a convergent series converges. However, if A sub n diverges and B sub n is greater than A sub n, then B sub n must also diverge. So we'll say B sub n diverges. The way this works is that if A sub n diverges, we know that A sub n is actually headed towards infinity. We know it's a positive infinity because A sub n is greater than 0. But B sub n is bigger than A sub n, so the terms of B sub n have to add up to more than A sub n. And A sub n is going to infinity, so B sub n must also go to infinity. So less than convergent converges, greater than divergent diverges. So the next question comes in, when would you use this? But you use it when you look at a series and you say that's really close to, and you pick a different series, but it doesn't quite match. So this series right here is very close to, the sum is n equals 1 to infinity of 1 over n cubed. And I would pick something like 1 over n cubed because it's easy to tell the convergence or divergence of this series because this is a p series. So I would say I'm going to compare to this series. And then I'm going to check for the convergence of or divergence of this series. So I know that this is a p series, which is of the form the sum of 1 over n to the p. So for this, p equals 3. And the important thing about p equaling 3 is that 3 is greater than 1, and we know that any p-value greater than 1 means that this series actually converges. So I haven't said anything about the convergence of the series I started with, but I have checked the convergence of the one I'm comparing it to. And it's called direct comparison. I'm directly comparing this series to this series. So the next thing I need to do is look at the test. If it says I have a convergent series and this series is less than my convergent, then this also converges. If it turns out to be greater than my convergent, I don't actually know if it converges or diverges by this test. So the next thing I'm going to do is actually compare the two, and the question is 1 over n cubed plus 1 less than 1 over n cubed? And the answer is yes. Any number I pick for n and I actually plug it into the denominator, this denominator is going to be bigger by 1, which makes the whole fraction smaller. So this inequality statement is true. 1 over n cubed plus 1 is less than 1 over n cubed, which means that this series here that I started with is less than the one that I'm actually comparing it to. So what that tells me is the sum from n equals 1 to infinity of 1 over n cubed plus 1 converges by the direct comparison test. So just to go over the steps again, you want to look at this and decide what am I going to compare it to. And what I'm looking at is what is this series closest to for something that I know how to actually do a convergence or divergence test for. So obvious choices that you're looking for is what if it's really close to geometric or what if it's really close to p series. This one is really close to the p series, and you can look at the dominant term in the denominator to decide that, a 1 over n cubed. So I'm comparing it to that. Then I decide convergence or divergence of the 1 over n cubed, and then I actually look at the size of each and then decide. So less than convergent converges, greater than divergent diverges.